Hi, and welcome to Interpreting Data to Solve Addition and Subtraction Problems, your second grade Math Dive in 5. I'm Shanna Uwe. For your first task, I'm going to have you pause the video. You can complete the task on your own or with a partner. You're going to solve for the answer and record an equation to prove your answer. So the task is, a group of students were surveyed about what sport they prefer to play. You can see the data below. How many more children prefer to play soccer and tennis compared to the number of children who prefer to play basketball? As you're working through the task, I want you to consider what would instruction need to look like in order for students to be successful with the task, and what do students need to understand about data and also reading data from tables in order to answer the question. So go ahead and complete the task. You're going to pause right here, and then we'll see you soon. Welcome back. First, we're going to look at progression with BEST with data standards. So in first grade, we collected data into categories and represented that data using tally marks or pictographs, interpreted the data with those same tally marks or pictographs, and used addition to find the totals of categories or subtraction to compare totals of different categories. In second grade, we're collecting, categorizing, and representing data using tally marks, tables, pictographs, or bar graphs, which could be represented horizontally and vertically. And the scales, as you can see that pop up, are limited to 1s, 5s, or 10s. We're also using appropriate titles, labels, and units when representing that data. We're interpreting data with the same scales, 1s, 5s, or 10s. And then we're also interpreting the data to solve problems involving addition and subtraction of whole numbers within 100. In third grade, they're representing data using tables, scaled pictographs, scaled bar graphs, or line plots. They're also using those same appropriate titles, labels, and units to represent that data. And once again, they're interpreting the data by solving now 1- and 2-step problems using information in a table, scaled pictograph, circle graph, scaled bar graph, or line plot. In this video, we're going to really cover the interpreting data piece in second grade, which includes solving problems involving addition and subtraction within 100. So when thinking about data in second grade, we want to continue that same CRA model that we use for other concepts. So our concrete may look like using Post-it notes to create bar graphs and then moving into snap cube towers. And then in pictographs, we might actually have a symbol that we're taping up as a class to represent that data. For representational, now we're drawing those bar graphs and those pictographs and labeling. And then we're moving to the abstract, where if you looked at that picture graph on the bottom of the representational, students first would just be talking about the data. I see 8 students chose lion as their favorite. 18 students voted for their favorite animal. And then moving into more complex problem solving with addition and subtraction, like how many students chose whale and giraffe as their favorite book. Well, I can see that there's 7 in the whale category and 2 in the giraffe, so all I have to do is add 7 plus 2 to get 9. Or a comparison, 5 more students chose whale as their animal rather than giraffe, so I can subtract those numbers and record that as an equation. So once again, CRA is going to be very essential for students understanding the bar graphs and picture graphs that they're representing. So looking at interpreting data, first we want to make sure we're using those appropriate titles, labels, and units when representing the data. We also want to make sure students spend a lot of time understanding what the graph or chart is about before they ever begin to solve an addition and subtraction problem using that data. So some questions that you could use to support students' interpretation of the data before they get to that problem solving might be, what do you notice? So just show the chart or graph and just ask them, have them explore. What does the title tell you about the graph or chart? So what is this graph or chart about? How many students voted? What does the key tell you about the data? How many students chose this category? So really just asking questions about that data to make sure they understand what's represented. And then what are the categories on the graph or chart and how does that affect the data? So once again, the purpose of this is just really diving into that graph or chart, understanding it. What is it made up of? What is it about? And then after they have that full understanding, we can move on to the next part with the problem solving. So as stated on the previous slide, students must first spend time understanding what the title, labels, key, data is telling them in either the tally chart, table, bar graph, or pictograph. So here we have a bar graph. So here are some questions we might ask. What do you notice? Well, and a student might say, I noticed one student chose pie as their favorite type of dessert. What does the title or labels tell you about the graph or chart? Well, I know it's about favorite desserts, and I know there's 4 different types that were surveyed, and so forth. What is the scale of the graph? Well, I can see it's going up 0, 1, 2, 3, 4, so it's 1. What does the key tell you about the data? So for this one, there is no key, but if it was a pictograph, we definitely would want to discover that. How many students chose cookies as their favorite? So making sure that kids know how to read that graph and see that it stops at 4, so that means 4 students. And then which was chosen the most? Well, it looks like cake because it has the longest bar. And then what was chosen the least? Pie, because it has the shortest bar. So now that students have spent time understanding the graph or chart, we can spend time having them answer questions involving addition and subtraction within 100. So for example, the first one, the same bar graph from the last one, we might ask how many more students would need to vote for pie to equal the votes for cake and cookies combined. We might have the picture graph that you can see in the middle. How many more students like the fruit with the most votes than the fruit with the least votes? Or even that tally chart, how many combined votes resulted in juice or milk? So once again, first they've spent time understanding the graph or chart, and now we're answering questions that require addition or subtraction. So students can connect back to strategies they use when adding or subtracting within 100 to solve the problems. So they can use the same base 10 models, they can use the same kind of equations, whatever strategies they used before, you want to connect here. So going back to the original task that you guys solved, a group of students were surveyed. How many more children prefer to play soccer and tennis compared to the number of children who prefer to play basketball? So it may take some time breaking down that word problem and looking for actions that tell you whether you're adding or subtracting or both. And you can kind of see the thought process here. First, I know 6 students played soccer and 8 students played tennis. So 11 students played basketball. So I'm just picking that data from that chart. 6 plus 8 equals 14. So 14 students play soccer and tennis combined. So the student identified that they need to combine those amounts first. Then 14 minus 11 equals 3. So 3 more students prefer to play soccer and tennis rather than basketball. So they spent time breaking down the data, picking the data that they needed, and figuring out how to use addition and subtraction to make that happen. So going back to the CRA models, first we want to start with those hands-on experiences, which could be creating a bar graph with post-it notes or snap cubes, or even making that picture graph using cutout pictures. Then we're moving into drawing the bar graphs or the picture graphs using that representational thinking, and then moving into recording statements about the data or solving using addition and subtraction. Once again, remember the only way to make those bridges really solid is to make sure that I'm going back and connecting the concrete to the representational and the representation to the abstract. And once we get to that abstract, we don't have to sit on that island. We can go back to those pictures and models as well. Thank you for joining me today for the Math Dive in 5, second grade, interpreting data to solve addition and subtraction problems. See you again.